Mr. Evangelist is a dynamo, and he draws crowd at Lake Taconic. He has a 12 or 13-inch telescope. He can delineate that further. And he is very excited to find things and show them to others, and a great asset to astronomy and to our organization. Mr. Evangelist is a Brooklyn person. I assume he was born and raised there, because he has 3 degrees from Brooklyn College, and also has been an adjunct professor at Brooklyn College. He has a degree in chemical education, bachelor's, master's in chemical education, and an advanced certificate in school supervision. And that's why he currently is the assistant principal of physical sciences at Brooklyn Technical High School in Brooklyn since 2002. And that's the year I retired, so you took my place. He started teaching at Brooklyn Tech in 1995. He has done work for over the last 19 years. It's my pleasure to introduce him tonight, and he can tell us a lot about the chemistry of our solar system. Mr. Evangelist.
Thank you, sir. Appreciate it. Okay, welcome everyone. Okay, down. Click. There we go. All right. So thank you again for the introduction. Yep, I did grow up in Brooklyn. 3-time CUNY Brooklyn College graduate. I don't even think I paid $18,000 for 3 degrees. Just so cheap. CUNY to be a teacher. CUNY was the way to go. So yes, and in the summers I used to just teach. It's kind of weird because like I would go to work and I have high school students learning advanced material, organic chemistry, astronomy. But at night at Brooklyn College in the summers, I was teaching chemistry for non-science majors. So it's kind of backwards, you know, but either way, always a good time teaching chemistry. Okay, so started as a teacher in 95 to 2002. The one thing that I was doing while I was being while teaching was I was actually watching my boss and what she was doing. And when she retired in August of 2002, I was all ready to go. Principal put me in, and somehow my retirement date got in there. not that I'm counting the days, but it'll be a full 25 years as an AP by the time I retire. Okay, good. Okay, did you do it? There you go. Is it showing up? There you go. All right. Yeah, that should be it. There it is. Perfect. All right. Okay, good. All right. So on the side, I'm working for the McGraw-Hill companies. Actually, I just retired, if you will, from them. But my contract ran out after 20-ish years, so I didn't renew. But the book on the left, the blue one, that's my first book. That was my, I was a sole author there. 2004, I wrote a book for the SAT subject test. Those exams don't exist anymore. So that's why I didn't renew with them. But whenever they needed an organic chemist or a chemist, I worked on the dental admissions, the nursing, the test assessing secondary completion. That's like the new GED program. So I helped McGraw-Hill write their book for that. And then the MCATs changed. Well, we started in 2014, but the MCATs changed in 2015. And most of the time when you have a proofreader, it's an English major. And not that there's anything wrong with an English major, but it was just, they would help you with your grammar, comma usage, your sentence structure, but they didn't review your math and they didn't review your facts. So that's why I was always a little bit of a commodity to them, let's say, because they always calling me. All right, so for tonight, let's take a look at astronomy from a chemist point of view. Okay, and we're going to look at why other planets or other places in the solar system are just not ideal for us to live. Okay, and some fun facts along the way, just to keep you thinking. Okay, and here's our first thinking. Okay, you have 4 pictures on the screen, and this has been the last couple of years. It's this is the top 2 I could see any morning on the way to work. Believe it or not. So it's been tough. Kids' mental health in school has been an issue, and the war. So it's been a little bit tough on the kids the last couple of years. Politics. You can look at any one of these 4 pictures, and immediately their thoughts. Okay, the thoughts come right into your head. Okay, I don't like this one, that one. Okay, it's gotten nasty. I don't remember it being this nasty when I was a kid, but as far as politics, people running for office and stuff like that, I don't remember it ever being this bad. Or maybe I just understand it better now that I'm older, but it's been tough on the kids. Solution, I'll move to the moon. I'm done with Earth. And so my nephew and my niece want to know, how come we aren't there? Okay, and it's why can't we just move to the moon? Look at the astronaut here. His spacesuit protects him. Look what he's covered in. Okay, he's filled with dust. Okay, this is actually a lot riskier than you think. Okay, that dust, in looking at the literature, it's as bad as asbestos, actually. Okay, he's covered in it. Supposedly that spacesuit's protecting him. He's covered in his face, his clothes. Okay, and there is something out there you can actually find. It's actually called lunar lung cancer. Okay, that's the term that they gave it. The ocular dermal irritation, and it's just that dust is just okay. Someday we'll go to the moon, and we can live on the moon. And actually, strike one for living on the moon. It's right there, the dust alone. Okay, then you have your temperature fluctuations. By the way, I'm going to use a lot of Kelvin tonight. Okay, so if you forget, I got one nod about using Kelvin. Kelvin's great, by the way. Always, for you students in the back, always use your calculations in Kelvin. This way you can avoid negative and 0. Okay, so go to Kelvin. You can't go wrong. I got 2 smiles, 3 smiles. You know the deal. Okay, so UV radiation. Again, you're not, there's no ozone layer to stop any UV radiation on the moon. And supposedly the American flag that was put into the moon soil, supposedly it's been bleached out by the sun's rays. And look, I can tell you right now, I'll put up a bulletin board in September celebrating student work, and the sun will shine on it. And by the time I change it in November, it's all faded out. Okay, the sun does that to you. So that's your UV radiation, exposure to radioactive particles. Okay, and then air. Okay, just the amount of air that you have up there, it's just times 10 to the 13th times less. Okay, so there's just nothing there for us. If we're going to be living on the moon, it's going to take quite a project. Okay, and then even worse. Okay, the craters are wonderful to look at, by the way. The first time people see it in a telescope, it's absolutely wonderful. But that tells you a lot. Okay, that moon is getting pelted with stuff. Okay, and we've had it. What was a couple years ago in Russia? Okay, it got hit. The meteorite exploded over the city. Glass was, the buildings were shaken and glass was broken. Okay, but at least we have an atmosphere that protects us. Okay, in the moon, you're completely defenseless against these strikes. Okay, and you could see, okay, it's happened before, and of course it can happen again. So we can pass on the moon for now. Okay, so let's make it even worse. Okay, how about Mercury? Okay, why can't we live on Mercury? Well, other than the temperatures, okay, the extreme temperatures and these extreme levels of solar radiation, you have no atmosphere. Maybe the only good point I could say is you'll celebrate New Year's every 59 days. Okay, but how you're going to transport all that champagne over to Mercury is beyond me. But again, it's just not a place for humans. Okay, and then Mercury, just like our moon, has had a rocky past. Okay, and in fact, I'm a bad teacher. I do this to kids all the time. Okay, but the thing you have to know is, the one thing I teach them is you have to know what you're looking at when you look at pictures online, because it's one thing to see it through your telescope. So what I did was I took out, when I was teaching the moon's phases, I took out pictures of the moon and I put crescent Mercury. Okay. And they're sitting there and they're looking at you like they don't want to say anything because they know the bosses. They don't want to, they're not going to go against me in class. Maybe they'll say something to me after class, but they're not going to start with me in class. So and finally, it's like, say what you want to say. And that's not right. Something's missing. And yeah, okay, but you have to know what you're looking at. I'm actually going to come at you again one more time in this PowerPoint. Okay, you have to really know what you're looking at because there's all this Photoshop stuff. Okay, but I'm telling you now, that's not Photoshop Mercury. Mercury's been pelted with stuff just as much as the moon has. Okay, so you're completely defenseless against the foreign objects. Okay, so is it safe to say Mercury's out? Okay, for life as we know it. Okay, so that's the moon and Mercury are gone. Okay, and then prelude to Venus. Okay, I haven't gotten to Venus yet, but let's have a little lesson in life. Okay, when life throws you lemons, you make lemonade, right? Okay, when you throw lemons to a chemist, we'll make lemonade, rust removers, and batteries. Okay, so why do I bring lemons into my presentation on the solar system? Think about the last time you were preparing to eat your lobster and you got some of that lemon juice on an open cut. And you're like, you don't want to say anything, and at the table, be like, oh, ow, it stings. Okay. Think about what that sting you get from an acid on your open cut. The National Fire, what is that? PI, I forgot the Prevention Association, I think it is. I don't know the whole thing, but with the chemicals in the lab, we get these sets of diamonds here. The blue is the health, the red is the flammability, the yellow is reactivity, and the white space there is for special comments. So this is citric acid. I don't think anyone has ever been cautious about citric acid. It's not very harmful to humans. But with Venus, okay, so what would be the problem with living there? First things first, it's not citric acid that you're dealing with your lemon juice. Now you're dealing with sulfuric acid. Okay, if you've ever had an encounter, I had one student who had, the encounter, right to the hospital across the street. Not that it was hazardous to his health, okay, but the burn was pretty bad. Okay, now you're dealing with two hydrogens. And I mean, it's nice. I mean, if you looked out west at night, of course, Venus is the brightest thing out there. Only the moon and the sun will outshine it. And it's this sulfuric acid that makes it very, very reflective. But there's something you should be aware of is that first hydrogen that comes off the sulfuric acid, 100% of the time it comes off. Okay. And then the second hydrogen comes off about 1% of the time. I'm estimating here just to keep it simple. Even an acid that gives off 1% of its H+ ions is already, you're talking a pH of 2-ish. Okay, so you're talking stomach acid-ish. Okay, so that's pretty bad. So again, it's just this hostile environment from the sulfuric acid. No, not for life as we know it. Another thing I love to teach the kids in astronomy class is that things that occur on Earth occur elsewhere. And that is, we have volcanic activity. You can find it, in other places of the solar system. The Earth is not the only one that has it. And the sulfur content on Venus, the volcanic activity and the sulfur content, it's high. And now you get this sulfur in the clouds, and you could start to make this sulfuric acid. Okay, and what does that do? Well, let's just estimate, because it can vary depending on how much water vapor is present. But let's say the pH was 1. Okay, acid rain on Earth is considered to be acid rain once you hit about pH of about 5.7, 5.6. Even the most remote areas on Earth still registered about 5.7-ish for their rain. And we have more than enough science projects. And I'm glad I didn't see it this year. Usually we get those science fair projects where the kids take plants, they pour acids on the plant dies, and they conclude that acid rain kills plants. Okay, that's, got it. Okay, we know that already. But if you really understand the pH scale, a pH of 1 on Venus and a pH, let's say 5 Okay, let's say we find acid rain to be at 5. Okay, you're talking powers of 10. You're talking 4 powers of 10. That means the pH, or the acidity of the clouds of Venus are 10,000 times at least more acidic than the acid rain we're facing off with on Earth. Okay, so we already know it corrodes the marble statues, and the writing on the marble statues goes, and then I don't know, they have a war hero with the statue and they lose the nose and they lose the eyes because of acid rain in due time. Okay, so on Venus, it would be that much worse, 10,000 times at least. Okay, so Venus, looking for life on Venus, that's gonna be tough. Okay, and some hot topics, here we go again. Okay, another societal issue here on Earth. It is a problem here on Earth, all right? So the temperature of the Earth has gone up. I get it. But what is the greenhouse effect done to Venus? And why can't we live there? Well, SO2, sulfur dioxide in the atmosphere, Venus, because of this SO2, is about 500 Kelvin hotter than it would be without. Okay, so that's an extreme temperature rise because of it. Now, how does that compare to Earth? We're about 34 Kelvin warmer than we would be without it. Okay, so all right, so maybe we do have that greenhouse effect here. Okay, if we didn't have it, we'd be 35 degrees or 34 degrees Celsius, cooler in temperature on average. But Venus is it's just hot. Okay, it's just no place for us to live. It's hot. It's got the acid content. It's for life as we know it. It's just not good to go. Okay, sulfur. I have to mention sulfur because I spent a lot of time on sulfur here. You can tell when someone has overcooked eggs. You walk into the kitchen, you could smell it. Someone was cooking something in the kitchen. You could tell eggs were there. Okay, overcooked eggs, you could just smell the sulfur, probably because the tertiary structure of the proteins, probably the disulfide bridges are breaking down. That's my best guess. But I didn't take the time to look that up. But there's this functional group called the mercaptan, or other people call it the thiol. Basically, it's an alcohol, except you've replaced the oxygen with a sulfur. And if you look at the picture on the top left, that is garlic. So why does garlic taste and smell the way it does? Well, the sulfur content is what you're tasting and smelling. Okay. And if you look at the onion and so on and so forth, I think this is actually more detailed on the garlic here. But there they found the 20 compounds plus. Okay, but even worse. And when you live in New York City for half the year, you don't think about it. But when I finally moved up here in December of 2018, it's like that smell of skunk. You can always tell. Okay, you're driving along. I was like, what the hell is that odor? It's just like, oh God, is that what I think it is? How bad is the stench of sulfur? These chemicals here, if your dog or cat gets sprayed directly, it'll kill them. Okay, skunks can kill another animal. Okay, another small animal with just a shot of this stuff. Okay, because the sulfur is it's just too much to handle. So either the odors or just the pH. It's just all these things here. It's the excess greenhouse effect. Okay, so that pretty much knocks Venus out. Okay, good. All right, now a really long work day. Okay, for me, okay, I only work 180 days a year. Okay, I'll be honest with you. Okay, and the rest of the year I do absolutely nothing. Okay, but okay, you would rotate around anyone trained to be a teacher here? No, all right, there you go. All right, good. Invest in your pension, by the way. Okay, so Venus rotates on its axis just once every 243 days, Earth days. Okay, but it rotates around the sun every 225 days. So you're actually going to celebrate New Year's before you even get a full work day in. Okay, if you want to think of it like that, kind of awkward. Okay, and if you're designing your home and you want to catch a certain sunset or sunrise, you just have to remember on Venus, the sun rises in the west and sets in the east, okay, because it's got that backwards rotation. Okay, so something to think about there, but just these little fun facts I put in there, but it goes around this, it gets around the sun, revolves around the sun just even before it rotates on its axis just once. So, all right, you'll be stuck with, light or dark. Okay, now, Mars. Let's see, what would be wrong with Mars? Growing up, Martians and all those movies used to watch back in the day, and Mars was this, it always seemed like it would be the place. If we were to live somewhere else, Mars would be it. You give me a few minutes, I'm going to shoot that down also. But but first of all, you can see the dust storms on Mars. They're there. You can actually see them with a telescope from Earth if you have a large enough mirror. And over time, you could see them develop and literally engulf large areas of the planet. But okay, so there's silicon dioxide in the Martian soil. That's great. But there's also iron 3 oxide or ferric oxide, Fe2O3. That's pure rust. Okay, so think about breathing this stuff in. So that's the first thing you would have to protect humans from, is breathing this stuff in. And think about when you were in the playground when you were a kid and you're running along and you fell, you hit the dirt, you scraped your knee, and mommy kisses it, makes it feel better. Okay, now it's filled with rust. We're not talking dirt. Now it's filled with rust. Okay, so you think about this stuff getting into your body. It's just not ideal for life as we know it. That would be one hell of a tetanus booster, that's for sure. And then there's this other class of compounds, or the inorganic compounds, the perchlorates. I think the level of calcium perchlorate in Martian soil, I think it runs about 0.5%. That's toxic. That's toxic to humans. And not only do you have to get past the rust, but to live on Mars, you're gonna have to get past the calcium perchlorate. And this thing is no joke, because this year, those bonds will resonance stabilize. This stuff ain't going nowhere. Okay, isn't going anywhere. Sorry about that. That's my New York accent. But anyway, it's just not, not for humans. Okay, all right. I said I grew up in the 90s. This song was popular when I was going to college. They wouldn't stop playing it. But seasonal polar ice caps. There's this sublimation. You can actually see, as the pictures show, when you take pictures of the poles, you can actually see the carbon dioxide, dry ice, come and go. And I use the word sublime in there. To have sublimation of carbon dioxide, what would be the temperature? About 195 Kelvin, negative 78.5 Celsius. So if that's the temperatures you're going to be enduring, and have you ever touched dry ice? Okay, if you've ever handled it, I used to take pure dry ice and I used to throw it right into the acetone to make a cold trap when I was extracting organic chemicals, and it burns. But here's the question I have here, and that is, what is the true definition of sublimation? A lot of people may be misled. Anybody from any of my students here want to take? Go ahead, Jack. Oh, no, all right. Well, notice I said the word true. I think that's what's scaring everybody off. Okay, so yes, solid to gas is sublimation, but it's really, sublimation is solid to gas with no apparent liquid phase. Interesting that they put the word apparent in there. At what point do we not see something, or what at the molecular level, at the atomic level, what's truly happening at the surface? And I can tell you, I love to ice skate. I do it about 6 hours a week. Can you ice skate on dry ice? Okay, and that's a good question. I'll leave that for you to think about. Okay, but can you skate? Because to skate, what my blades do is they change the solid water to liquid water underneath the blades. That's what lets me glide across. And does that happen on dry ice? Okay, so I'll leave you with that question. Okay, can you skate on dry ice? Okay, so, and a chilly weather report for Mars. Okay, so the cold temperatures, the soil. Okay, as you can see here, there's a lot of properties in here. They put it together nice. Very little atmosphere. You'll get day and night is almost split in 12 hours. But you'll love the sunny weather, but the freezing temperatures. Okay, the soil, the freezing temperature, not a place for humans. Okay, have I made my case for Mars? Okay, good. Okay, so I'm leaving my inner core rocky planets. Okay, I'm going to move on to the gas giants. First problem with Jupiter. Okay, where do you even land on a gas giant. It's just, living there, forget it. So 70%, two ways we measure or quantify things in chemistry is one by mass and one by volume. When you're talking percentages, you always have to specify percent by mass or percent by volume. So it's composed 70% hydrogen and 25% helium by mass. But when you look at the volume, it's 90% hydrogen and 10% helium by volume. So the question is, what can you calculate using mass and volume? The answer is, I'm hoping here, density. Somebody said, you said density, very good. Okay, so yes. Okay, now, the density, how do you keep this big ball of gas together? Okay, there's helium, there's hydrogen, the gas is here, whatever they be, you can't even see them. How do we get it to stay like this? Well, the density here, chemists, we calculate density in grams per liter, by the way. 1 molar volume is 22.4 liters. So when we look at the density of gases, we do it in grams per liter. But there's only one thing. STP is standard temperature and pressure. That's it's 273 Kelvin, 0 degrees Celsius, 1 atmosphere, 1013 millibars. Okay, this planet here, it's so cold. All that, you're not dealing with STP. So that's why you get the differences in mass and volume here. Okay, now, one thing that nobody really talks about, I mean, you could take pictures of Jupiter and you'll see the spot move, the red spot, you'll see it move with time. I like to take pictures of Jupiter and maybe like over the course of the evening, see which way the moons have moved. Okay, and look at the difference, and maybe a moon has appeared or disappeared in front or behind. But what they don't tell you is that what you're really looking at, those bands are actually moving at around 250 miles an hour. So that's why you get all those storms. You get that crisscross of the winds. So that's where you get those storms. And it's just, this data has been recorded. It's just, this is actually the calmer one of the 4 gas giants. I'm going to show you the data for the other gas giants, but it's just very, very harsh. Okay, now a little physics. Okay, I'll step back from the chemistry here. If you were at the surface, let's assume that you had a solid surface on Jupiter, and okay, your acceleration due to gravity would be about 26 meters per second squared. Compare that to Earth at 9.81. So, okay, so if I, horror show for kids in school, they drop their phone and it cracks, and oh my God, how am I going to talk to everybody on Zoom? I mean, on Facebook, whatever it is. So the force of gravity on Jupiter is about 2.7 times greater. So let's say it were a solid surface. We're back at the playground. Forget falling in Martian soil. Now you fall off the swing. Okay, on Earth, all right, you hurt your hand. Okay, you get a cut. Here, now you're talking broken bones. Okay, so it's just that much greater, and the force is just that much greater when something falls. Okay, it's, again, something else to think about. And the stormy weather, okay, now, I don't know my fellow older astronomers here, but do you remember when the Great Red Spot was great? Okay, it used to be, when you saw it in a telescope, it was the Great Red Spot. Okay, I don't call it the Great Red Spot in class anymore. It's just not what it used to be. Anyway, yeah. All right, let me just move on here. Okay, so Saturn. Okay, take a moment here. After everything I've done so far, what would you expect to come into play? What were you thinking? Go ahead, throw it at me. Say it. No solid surface. High winds. I'm being very negative here. Okay. Cold temperatures, you got it. Okay. Yeah, it's all the same stuff once you get out there. Okay, so there has to be balance in life somewhere. So I have to say something positive eventually. Okay, so of course, dear to my heart. Okay, and a whole bunch of chemicals. Again, hydrogen, helium, I got it. Methane, well, you don't have to really worry about it catching fire. I guess there's not as much oxygen out there. It's the first time I'm saying oxygen today. I haven't even said water yet either, but we'll get to that. But ammonia and ammonium hydrosulfide. Okay, it's in the cloud layers. It's just not an environment that we know that can hold life. It's just not, yeah, it's just not going to support life as we know it. Okay, but the rings are cool. I said I would be positive. There's going to be balance in life. If you haven't seen the rings of Saturn through a telescope, go see them. Okay, is there anyone here who hasn't seen the rings of Saturn? Okay, good. All right, good. Okay, go see it. You got to see it live. And the first time you show someone the rings of Saturn through a telescope, they're like, "Oh, when I put my eye to the eyepiece, you're holding up a picture. Cut it out." It's not. It's no. That's really what's there. And what's great is, if you look at the pictures you take over the years, you'll see how the tilt varies. Okay. And here's just a sample. Okay, through history. Okay, and every couple of years you'll notice it a little bit more. Okay, so now, by the way, I said I would come back to knowing what pictures you're looking at. How many of the solar system planets have rings? How many? 4. I got 4 here. Agree, disagree? Do I hear 5? Do I hear 6? No, it's 4. Okay, now, but you have to know what you're looking at once again. Okay, so I purposely jumbled them a little bit here. Okay, which one is which? Okay, so Jupiter, Saturn, Uranus, and Neptune all have rings. Which one is which? Upper left? That is Uranus. Upper left is Uranus. Okay, you have to know what you're looking at. Bottom left, that is Saturn. Good. All right, I gave you an easy one here. Okay, upper right, that's a layup. Okay, that's Jupiter, and bottom right would be Neptune. Okay, just like I did with Mercury and the Moon. Okay, I like to, play with the pictures. You have to know, because there's, for kids, they just run to this generation. They just run right to the internet, and they'll find anything off John and Bob's 99-cent website. Okay, and I can tell you as an author, no one's giving out the best information for free. Okay, that's why you go to the library and read the book. Okay, pick up mine too while you're there. But anyway, okay, so let's just move further out here. Uranus and Neptune, I put this in here that they're feeling blue. I don't understand what it was, but I really tripped up my students on a test, which one was bluer, Neptune or Uranus, on a test. And I don't, maybe I wasn't very clear in class. So from that, after that first exam, I made sure I was very clear about which one is bluer. So, but there's methane, there's other hydrocarbons. And actually on Neptune, you're gonna, you could actually look it up, there's actually hydrocarbon lakes. Okay, methane is a gas at room temperature. At what temperature does methane become a liquid? Okay, and I know helium, think about this for a second. Helium boils, okay, from liquid to gas at 4 Kelvin-ish. Give or take a little. How close am I? 1 sig fig. Okay, I went to 1 sig fig. You got 2 sig figs. Check. Okay. So, it's to have methane, to have hydrocarbon lakes, it has to be pretty cold. Okay, and here I keep talking about New Year's. So a lot of my teammates in Brooklyn, they're all Russian, and New Year's is the big party for them. It's that one celebration of the year that's over the top. So you can go 84 years. If you don't live to be 84, you won't have New Year's on Uranus. And Neptune, I think we just celebrated a new year. We just had a New Year's party. The science world had it for Neptune. It was 165 years. What year was that? 2012? So I'd have to look up the years, but actually since its discovery, 165 years had gone by, and actually the astronomers had celebrated the New Year's of Neptune. And just feeling disrespected. I mean, they were actually our ancient ancestors. They knew about the wanderers of the sky. Okay, but Uranus and Neptune were not part of that. Okay, so I don't know if you saw it, if I have to go back, but you'll notice that Uranus in the top left, an approximate 90-degree angle on this rotation. Actually, I think it's closer to 97, but okay, from its orbit. Okay, Uranus also has that rotation that goes in the other way than the other 6 planets. It's actually backwards, if you think. Okay, and why does Neptune look to be bluer than Uranus? the high winds, and I'm talking like 1,200 kilometers per hour here, okay, on Neptune. All that methane that would normally sit at the surface, it's all stirred up higher into the atmosphere, and that gives it that deeper blue color. Okay. All right. Now, so if we were to live somewhere else, okay, it's amazing how in school, okay, if there's a line to see me outside my office, kids get impatient. Okay, but if it's a ride at Disneyland, they'll stand in the 90-degree heat to go on a ride that goes up and down in 10 seconds and everyone's happy. Okay, if you had to travel, okay, if you have to travel with kids in the car, remember that 1 AU from, let's say Earth to the sun is 93 million miles. So even if you had to travel from Earth to Mars, the shortest distance you would get is 0.5 times 93 million miles. So even, what was it, New Horizons, before it got to Pluto, I said planets and I say Pluto, everyone's shame on me, but to get to Pluto, I think it took 9.5 years before it finally arrived in July of 2014. I think it was on a 9.5-year mission, and how fast it was traveling. So even if we wanted to leave Earth, just the time it takes to get to other places outside off the planet, it's just ridiculous. And if you put things in perspective, when I look at this, I think of the Bohr model of the atom. Okay, what is the atom really? It's empty space. When you really get to the subatomic particles and you look at this, what's the solar system really? Empty space. So one of the projects we do in school is the kids take 200 sheets of toilet paper, take a roll of toilet paper, and they measure out 200 sheets of toilet paper, and it goes all the way down the hallway. And they put the planets in a relative position to make a scale model. And with one step, I can go from the sun to Mars. Okay, but to get to Neptune, you don't realize how far down the hallway you really have to walk. Okay, so just the travel time, if you had to go to another planet, yeah, not even reasonable. Okay, now let's be optimistic. I said there's balance. Okay, there are exoplanets out there, and there's something called the Earth Similarity Index. So, maybe it's possible someday if we could travel that fast. I doubt it, but there are other planets out there like us. And I didn't know that this index had existed until I found it online. But there is a measuring system for exoplanets, how much of a habitable zone it would be, or how much correlation. So, all right. Now I opened up with some dreary pictures. Okay, so I want to close with some good stuff. So here, I haven't said oxygen. I finally said oxygen. I haven't said water. I finally said water because those are the two things we need. I haven't said that for the other planets. But what's so special about Earth? Well, you guys. Okay, kudos to you. For me to move out of New York, what did it take? It took one ride up the Taconic and set up my telescope in complete darkness. Okay, so I'm hooked, called the real estate agent. I was closed in 6 weeks. Okay, and hockey's good. Okay, every summer, well, actually last summer, I was a practice goalie for someone from the Ottawa Senators. Okay, on the NHL team, and if hockey weren't on Earth, I'd be devastated. Okay, I work 5 blocks from Junior's. Who here has tasted Junior's cheesecake? Oh my God, the apple crumb to die for. 5 blocks from where I work. Okay, anytime I have special guests over to the school, that's exactly where we go for lunch. Sorry, guys, New York style pizza still wins. Okay, I think it's because of the New York City water, actually. But I've actually been in places up north where they've asked me to bring pizza from New York, upstate. So, okay, Brooks Brothers, because the secretaries at work are staring at me. Okay, good. Anytime I'm winning, I play chess. It balances my life. I start losing. Okay, and that one course that scared your doctor away from being a doctor, okay, that's what they call hell, I call home. This is actually my field of studies. That's what a great subject. You get an A in organic, you're going places. So, all right, well, thank you very much, ladies and gentlemen. I appreciate it. Okay, spending time. So, and if you have any questions, you can always email me or, okay, whew, okay. I kept it under an hour.
Yeah.
That's 45. That's what a class period would be, is about 40 minutes.
Want to take questions now?
I'll take questions. Sure.
What about the moons of some of the outer planets?
Yeah, you know what? Something. It's funny you mentioned that. Well, let's say, for example, Phobos and Deimos, around Mars, you're going to get an atmosphere, you're going to get the temperatures, but I didn't look into the soil there, the soil content. But the one moon that's always interested me is Io. Okay, I always tell the kids, if you're going to study one moon, study Jupiter's Io. Okay, just because, like I said, the processes that occur on Earth occur elsewhere, and Io, just the volcanic activity. I've always found that to be most interesting. But I don't see those being habitable either. It's way out of our habitable zone. So, yeah, question. Yeah. That's true. That's true. Yeah. Oh, do they? Okay. This is my first time in New Paltz. Okay. Yeah, further up north, it's something, it just doesn't taste right when you're from New York, and the pizza upstate just doesn't taste as good. But now I know. It's my first time here for sure. Actually, I had invited one of my former students to here tonight, and I thought she would be here, and actually it turns out she graduated a semester early. And I said, "Hey, good, good. She missed it here," but I was hoping to talk to her. But we haven't. But she was telling me that quite a different environment from New York City, for sure. So, other questions? No. Yes, sir. Oh.
So I find that it's really interesting to see the differential in the winds
Oh yeah.
on Jupiter or Saturn. But my question is, since all speed is relative to what? What does zero mean on this compared to, especially if there's no surface to this, no defined surface for this planet?
That's true.
What is it?
I guess that would be the rotation.
Of what? The rotation of.
That's true, because it's moving opposite directions and moving in the same
Right. I mean,
direction.
you
Would be,
could-
yeah,
you could
sure.
pick zero. I imagine you could pick zero to be anything. And then the speeds relative to them would be the same. But what sets the 0 point in this kind of graph? And I don't know if you know the answer to that,
No.
or somebody else does, but
I tell you, but most of the time in chemistry, like there's always that one element that's your reference point. So that's just it. I think that's the key there, is where's the reference point? And even in a physics problem, we set the reference point if something's going up, down, which will be negative, which way will be positive. So
Well, given this particular diagram, I think it's relative to the position on the planet. You're talking at the North Pole, you're looking at winds that are, some amount, but at the South, you're looking at zero. So it looks like it's relative to the,
at the
winds at the South Pole.
anything at all either, because it's a fixed point.
Mhm.
I was wondering if it averaged out. Can we look at Jupiter? Yeah, that maybe, no, that's
Probably not.
still
It's-
has more of a speed.
it's looking like it's relative to latitude, but you're right about
Yeah,
in reference to.
The average does not.
so if the winds are favoring one direction on average, then what is it relative to? The core? Relative to our.
That's what my thinking would be.
probably, yeah.
Well, how do we know the period of the planet if all of these different things are moving, especially if the red spot is clearly moving with negative speed, or these are the wind speeds?
Well, if
These are
it's
wind
the wind
speeds.
speed, you're looking at the red spot's rotating anti-clockwise.
Right.
So your wind speed would be to the left at the top and to the right at the bottom
Right,
The
that's
center would be moving at
at relative
whatever. Okay, so
zero.
these
Yeah,
may be rotational speeds.
yeah. Relative to our point of view.
yeah. That's just it. What is your reference point?
Yeah. There's this, like a jet stream is relative to Earth's surface, but there's no surface here. But for the red spot being a circulation, the center is like the eye of the storm, and it's zero winds at the center, so that might be a reference point. Right. Not just that one point. Right. Or maybe it's measures, the differential.
I'm thinking if you're looking at it from Earth,
Yeah.
and you know the diameter of the planet, let's see, at the red spot, and you see it come around every, every 24 hours or whatever it is, you now can calculate a speed of sorts.
But if you look at the white spot, which nobody pays attention to, but it's in the northern
Yeah.
hemisphere,
I don't know,
I've been paying attention to
was
since
it-
I noticed there's a spot. It's
Did-
just not red.
Was it measured by redshift, blue shift?
Oh, redshift.
That's,
the red spot.
I don't know if you want to go in there.
Away from us, right? Yeah.
So is it redshift, blue shift? Listen, the doctor can do it with the blood on going through your artery. Yeah, so it's, for sure, but,
I was just puzzling.
All right, supposing we had infinite sources of energy, which
boy.
planet would be easiest to terraform?
oh, boy.
Where's there?
I've
oxygen
always
locked
thought
away?
it would be, I've always said Mars. I've always thought it would be Mars. One of the kids in school told me that they had done their work and research, and Mars being inhabited by humans is only 300 years away. Okay, so, okay. And I was like, wow, okay, that's great. Tell me how it goes. Okay, but I don't know, just that's why I looked at the chemical environments. I mean, you could, it's just,
Yeah, but let's say you create an atmosphere.
you create an atmosphere and then you have to sustain it.
Because there's no protection, there's no magnetic field to protect.
That's
it.
what
That's
I
a whole
was
other
Constantly
issue, yeah.
stripped By the sun, by the solar.
Yeah, and then, magnetic fields, I didn't even talk about that with Jupiter. Okay, that was getting involving and how the particles would form a helix along the magnetic field. And yeah, so that's a whole other thing. But if you're talking electronics, forget it near Jupiter. Okay, because the magnetic field is just, I think they would give me some ridiculous numbers, like 18,000 times greater. So,
But life on Earth really depends on having a magnetic field, and Mars had one at one point, but it
At one-
lost it.
okay,
So it lost that.
yeah,
So
yeah. So, but,
And then, and on Io, I think you have the same, you still have the intense magnetic field when you get farther away, Ganymede is like livable.
hmm.
Yeah,
But yeah, it's which one? I know the kids in school, they always tell me Mars. Mars seems most feasible. So I said, all right, but which one? I won't be there to find out. That's for sure. It's just so far away. What you would have to do to put it all together, that's a massive undertaking.
I think I was hearing that Titan had good prospects because it was a reasonable temperature and pretty close to 1 atmosphere of pressure. So you wouldn't
No,
need
is
too
it-
much of a suit.
Okay, Titan. Okay, interesting. But and your guess is as good as mine. But the kids have always said that it's Mars that they would think they would be most on their research. But it's the most. Yep. Okay. Question.
What would the perchlorates do to any pure metals that landed on Mars?
Perchlorates with metals. Well, I know HClO4 would be a strong acid if it's a reactive metal. I mean, really the only metals that would resist, well, I'm talking acids, but perchlorates with metals. Well, let's see, ionic.
It oxidizes.
I'd have to draw that out, actually. Don't use any, the only perchlorate I'm actually familiar with that I've actually used is HClO4. Okay, and the only metals that would resist reacting with that I have available, gold, silver, and copper. for the most part.
So if you put water on Mars, all your spaceships are gonna rot out.
That's a whole other issue. Yeah, but that's more, that's true of salts in general, but definitely when you live by the ocean, I know one of my teachers has a house in Puerto Rico, and he says the salt water wreaks havoc on your paint, on the metals, everything's rusting. So, but that would be interesting, thing to see. But the perchlorate ion reacting with a metal, I'd have to work that out and see what that actually gives. But I know for sure HClO4 is one of the 6 strongest acids. After these 6, everything else is considered weak, and then you have to look at Ka values to see how weak is. But I would say you would have to make things out of copper, silver, and gold to give you best chances of not reacting. I think those are your 3 least reactive metals if you wanted to resist that ion. Not very hard, no, but as far as reactivity, yeah, gold, I mean, gold, you just don't find it as an ion. Okay, you always find it, for the most part, you'll always find it as solid. That's because the ion, as soon as the ion forms, it favors gathering 3 electrons to making the solid. And the silver ion, as soon as it forms, it wants to gain 1 electron to form the silver. And copper, it'll be 2 electrons, but once they're in their metal form, reactivity, okay, as opposed to lithium, okay, let's say the lithium ion battery, lithium can't wait to get rid of an electron, okay, and become an ion. So, lithium would be a different story. So, question?
A large part of Jupiter is metallic hydrogen.
In the core.
Yeah, so
further
what
down, yeah.
state is that? Is that a liquid? Is it a metal? Is it a extremely dense gas? Our definitions
Metallic
not work?
core. Offhand, I don't know the phase. Would it be liquid? I'm sure it would be mobile. Okay, I would,
I've always heard it.
to be
always heard it
pure
referred to as a
solid would be
liquid metal.
pretty hard. It should be liquid, right?
Yeah, liquid metal is always how I've heard it defined, which is always,
Yeah.
yeah, it's kind of a weird way to
It
say
has
it.
to be mobile. It has to be able to. It's kind of like the molten center of the Earth. That's what I would think would be the ideal answer.
Any other questions on the Zoom session on the web? And any further in the room?
Nope.
All right.
Cool. All right.
Marvelous.
Cool. All right. Thank you.